Hi everyone, we're going to continue in 2.7, which was all about combining functions, and we're going to talk now about the composition function. So first of all, let's start with a definition. So again, we are going to be combining more than one function, so we're going to be given two functions. You can have more than two, but we're going to start with two. So we're going to have f and g, and we're going to talk about the composition function. The composition function. First of all, the way we'd write it is f with a little circle. That's an open circle, so it's not a multiplication. G. And the way it is defined by f. So it's read f composed with g of x is f of g of x. So that's how you would read this. F composed with g of x is equal to f of g of x. And we can remember when we do order of operations, we start on the inside and we work our way out. Okay, the domain here gets a little bit tricky. So first of all, the domain is going to be the set of all x's. Well, I should write it this way, the set of all x's, such that g, well, first of all, x is going to, let me think if I can get this right. X is an element of the domain of g, because we have to be able to calculate g of x first, such that g of x is an element of the domain of f. Like I said, it's kind of complicated. So I'll try to draw a little picture to make it a little bit clearer. And not that you need to have all of that kind of down, but you kind of have to remember where things come from. Not always looking at the end result, kind of know where they came from. So here is going to be, first of all, our domain of g, because that's what we're going to have to do first. We're going to have to take a little x guy found in here, and from g, so we're taking g, whatever g tells us to do, it's going to map us to some g of x. So this would be the range of g, but also it has to be inside, so I'll call this, that's going to be the domain of f. So there might be some stuff in here in the range of g that we can't use. So that stuff would have to get thrown out. And then we're going to take f and we're going to map that new point into the range. So this is going to give us f of g of x. If we use our new notation, it's called f composed with g of x. So let's look at some examples. And let's look at the examples that we'd used before. So we had f of x equal to x squared minus 3. My g of x was the square root of x, and h of x was, sorry, I'm going kind of crooked here, 1 over x minus 2. Okay, and just as a reminder, I'll put our domains, all real numbers. We had the positive numbers, and here we had everything but 2. We had to throw 2 out, because that made a 0 in the denominator. We couldn't use negatives because that gave us a square root of a negative. Now let's do some composing. Let's see what f of, let's use h, looks like. Okay, I'm going to write this out longhand a couple of times, going through all the steps, and then I'll probably start skipping a little bit. So this means we're going to do f of h of x. Okay, that's how it's defined. So now h of x is this thing. So that means we're going to do f of 1 over x minus 2. And then we're going to take this 1 over x minus 2 and we're going to substitute it in here. So that's going to give us 1 over x minus 2 squared minus 3. And just to save some time on the video, we would then simplify this. So in other words, you would square that out, probably get a common denominator, and bring it all together as one fraction. So you would want to do that extra algebra to simplify that. So make sure you get used to possibly doing that extra step. Just to save length of the video, I'm going to leave that for you. So this would be requiring you to square this out and then getting your common denominator and combining your fractions. All right. Let's do another one. Let's do, how about g of f of x? So this is going to be g of f of x. So that means f, that's this guy. And I'm going to put this in here. So we'd have that square root of x squared minus 3. Now one thing to note is we cannot break up and take the square root minus a square root. It does not work that way. We can only do that if this was multiplication, not subtraction. So this is stuck just the way it is. Okay. Now if we were trying to find the domains of these things, just going to talk through it. We're not actually going to do it because it's not something that we're going to stress on in this section. This one we'd want to could be all real numbers. Again, we'd throw out the 2 because that would make that denominator 0. Here we have to be a little bit more careful because we would need to make sure that this x squared minus 3 is bigger than 0. So we'd have to have this x squared minus 3 greater than or equal to 0. We haven't figured out exactly how to solve that yet. That's coming up in a later chapter. Hence the reason we're not going to spend a lot of time working on domains of composite functions, because it can get very, very complicated. Okay, let's do a couple more. So let's see here. Keep my F, G, and H there so I can see them. Let's do F of G. So again, I need to do F of G of X. And I like to write it this way. For me, it tells me which one's going into the other one. So I'm going to be taking G and I'm going to be putting it into F. So I'm not necessarily going to write that next step. So I'm going to take my G and substitute it in where I see that X. So I will have that square root of X squared minus 3. So you can see that G going into the function F. Cleaning this up a little bit is going to give me X minus 3, because the square root of X squared simply gives me X, provided, and this is where we need to kind of put probably some qualifiers on here, because if I look at this, this has a domain of all real numbers. However, we have to make sure we could do what we started with, which means we have to make sure that we can take that square root of X first. So this is equal to this, provided we are still in that 0 to infinity domain. So, And that's where mathematics starts to get a little bit more sophisticated. A lot of times we do write these equal signs in here, but before this class, and certainly the ones that are going to follow, we didn't always write this 4x piece on there because we don't want to lose that domain idea. A lot of times we will still sometimes, even in this class, forget to put this little extra piece in here, but start thinking of those things. Can I say that these two things are equal? And this is true provided your x is still in 0 to infinity. Okay, I'm going to stop this video here. I'm going to come back with some, oh wait, I'm sorry, I am not going to stop this video here. I'm going to do one more problem that comes from a calculus concept. And students always are like, they have no idea what we have. So I'm going to come up with a function here. So we have the 4th root of x plus 9. So we have a capital F equal to this function. What we want to do is we want to find two functions. And we will call them f and g, such that f composed with g of x is equal to capital F of x. And students, for some reason, think that that is a very complicated situation because they're like, it makes no sense. So we're going to break it down. We want to find two functions. Okay, two formulas for something. So that if I have this, it equals that. So somehow I've got to look at this and come up with two functions. I'm going to rewrite this guy again. Okay, that's f of g of x. So what they want you to find, or what they want you to look at, is look at this function and picture, do you see a function inside of another function? Do you see a function inside of another function? So if I'm looking at this, I see this x plus 9 inside that 4th root. So since I see that, that means my g function. That's going to be the inside piece. So that's the inside function. And the function it is inside of is that 4th root. Okay, you can't have the 4th root of nothing, so you have to have the 4th root of that piece. And if you check, if I put this into here where the x is, I will get that. So all they're trying to get you to do is start seeing functions inside of other functions. That's all they want you to see. Can you see a function inside of another function? Okay, now I'm going to stop the video and come back to one last topic, because we're going to look at these combinations. Instead of having functions in terms of formulas, we're going to see them in different formats.